Good evening, sir.
Yes, good evening.
How are you, sir?
Yeah, fit and fine.
Can we start, sir? They'll join slowly. Can we
Yeah,
start?
not a problem. Yeah, sure. They should learn to.
So, good evening to everyone. We are assembled here for the online international workshop on statistics using Jamovi. So, we have with us our resource person, Dr. Paraksha, sir. Paraksha sir is, as told earlier, sir is Associate Professor in HL College of Commerce, Ahmedabad, Gujarat. So today we are going to see about non-parametric tests. What is the title today?
Yeah, it will be mixture of both parametric and non-parametric. So it is one sample and all we'll be taking it.
Okay. Okay, sir. Thank you very much, sir, for coming to our session again. Welcome you, sir. The session is yours.
Thank you. Thank you, madam. So we hope that up till now, at least you have taken some of the practice one, and it would be a little bit of hands off that you have already taken up, so that you are familiar with how it is done using Jamovi and all. So what I'll do today, it will be totally hands-on today. The conceptual part has been discussed at length in my previous session. So today it will be a totally hands-on session. I'll be covering, I'll repeat actually, I will say, I'll repeat one sample t-test. I'll repeat that. I will take correspondingly what is a non-parametric test for it. I'll be taking two sample t-tests and corresponding non-parametric test for it. I'll be taking pair t-test and corresponding non-parametric test for it. So we will go with parametric and non-parametric together so that the concept of parametric and non-parametric is clearly differentiated when you do it simultaneously. Jamovi has that added advantage compared to all other tools where parametric and non-parametrics are clearly defined when and how to do it. Okay, so now we'll start with the the data set that we have already taken care of. But still, I'll repeat that point again. Is the screen visible?
Yes, sir. Yes, sir.
Okay. Just do one thing. Everyone write down that it is visible so that I can understand how many are live right now. I want everyone's. I can see the name also. So write down in the chat box that it is visible. Mandapati Kiran, Lata. I want everyone to write down, please. Joy, Jyotish, Bhagyalakshmi. Okay, that's good. Okay, Bhagyalakshmi, Mohandas, Baby Jyotish, Veena, Lata, and someone from MS University, Baroda. That's good. Ekta, Mandapati Kiran, Pushpa. Still, who is left out? Make it fast. Goana, Dr. Agustin, waiting for you. Ilonga, Kiamuta, Nalini, Princey, Kanchan, Miruna. I want from you also. That's good. Okay, Subhasini. Right. The numbers are increasing. That's good. The purpose is just I want everyone to be over here so that we can in detail discuss about how and the parametric test should be done. So now, without wasting time, okay, Amuta, it is visible, Ilonga, that's good. Open up your Jamovi file, blank Jamovi. If you want to do it along with me, or else I would suggest you can simply write down the steps and then you can it is taking a little bit more time. Okay, it will be very interesting session today because there is no concept required now. Everything has been cleared, but still I'll go it step by step. I'll go a little bit slow, but it will be step by step. Everything should be clear. Sure. This we have already discussed. So I'm not going into this example also. Yeah, we'll start with this example. A researcher is investigating hemoglobin level of schoolgirls in a particular area. 15 schoolgirls were randomly selected and their hemoglobin levels is as follows. Means it is collected in a file. Which file? You already have that file hb_girls.xlx. What is the question asked? Does the data reveal that average hemoglobin level among the schoolgirls is more than 11.5? That is the question. Now understand, I'll go with exact the same 5 steps that are required. Which were they? Everyone, which were the 5 steps? Step 1 and 2, null and alternative. Step 3 is the assumption checking. Step 4 is the test statistics and p-value. And step 5, conclusion by comparing p and the level of significance. We'll do the same step. Okay, so now, if I start with the steps, I'll go with the solution. So we'll start with step 1 and 2. I'll explain as if we are doing on board. Okay, what is the question asked? Does the data reveal that the average, so one thing to focus over here is average, hemoglobin level among schoolgirls is more than 11.5? So the question is asked, is it more than 11.5? So what can be our answer? Yes or no? Okay, there are only two answers possible. You can start with any one. I will start with, say, hemoglobin level is more than, how much it was? 11.5. Is it more than 11.5? I'm saying, yeah, it is more than 11.5. 11.5. What does this mean? Average means mu. More than means greater than 11.5. What will be complementary to this? If I say greater than 11.5, which are the options left out? Which are the options left out? Mu less than or equal to 11.5. So this means hemoglobin level is not more than. You can also write down less than or equal to. That's absolutely fine. But generally what we do, more than 11.5, what will be complementary? Not more than 11.5. Out of this two, where you have an equal to sign, we have an equal to sign over here. So this becomes our null hypothesis, which is H0. This becomes our alternative hypothesis, that is H1. Make sense? Everyone, clear with this? Done. That okay. Step 1 and 2 is done. Step 3 comes to assumption. What is the assumption we need to check? Normality assumption. So what we do in normality assumptions, we assume that hemoglobin level is normal. Means our decision variable. What is our decision variable over here? Hemoglobin level. So we assume that hemoglobin level is normal, and alternative will be hemoglobin level is not normal. How it is checked? How it is checked? Using Sapir-Whorf test or QQ plot. Okay, so now I'm doing it with you. I'm opening my file. I'm going into this, open. I will check out where it is. It is one sample in one sample data, HB girls. So that is open. I hope everyone has reached up to this. What you have to need to check, you need to check this HB. See my cursor. Raju sir has taught you that you have to check HB is a numeric variable or a scale variable. So you can see here the notation. If you look at the data, it will explain you. In the data, it will explain. If I go into variable, here it is giving you HB. If I click on this, it is showing me it is a continuous. Means it is or nominal, ordinal, continuous. It is a continuous. That is how you can check whether your hemoglobin is continuous or not. So that means whether Jamovi has taken your variable properly or not. Now, data has been already now fed into Jamovi. Everyone is with me? Okay. I want to check whether it is normal or not. Where to go? In analyze, in exploration. I repeat again. I want to check normality. Normality means we have to go for Shapiro-Wilk test or QQ plot. So what I'm going for? In exploration, go into descriptive. When you open this descriptive, a new window will pop up. Here is a new window. Out of that, which is our variable? Hemoglobin. So select that into variable. So here we should get hemoglobin. Got this hemoglobin? You can see on right hand side. By default, the descriptive has already been done. It gives you that there are 15 observations, there is one missing value, mean is 11.3, median is 11.5, and so on. Everything it will give you. But we don't require this right now. So I'll go into statistics. In statistics, I don't want n, I don't want missing, I don't want minimum value, I don't want maximum value. These are all extra values. Right now I don't require. What I require is I require Shapiro-Wilk. So you can see automatically it calculates the Shapiro-Wilk. What is the value of Shapiro-Wilk? If you see the test statistics, it comes to 0.949 and the p-value comes to 505, 0.505. So here coming to this, I'm using Shapiro-Wilk. My p-value is coming it as 0.505. What to compare with? It is always alpha. And if nothing is mentioned, what is our alpha value? 0.05. Compare. We get p greater than alpha. Remember, when p is greater than alpha means what? Therefore, we say when p is greater than alpha, therefore we say we fail to reject. We fail to reject null hypothesis. In other words, fail to reject means what? We accept. What we accept? The null hypothesis. What is the null hypothesis? HB is normal. So we can say HB is normal. That means normally distributed. Hemoglobin is normally distributed. That is what we have done. So step 3 is done. Done up to this, everyone? Hemoglobin is normally distributed. Write down in the chat box if you have done it. Come on, fast. Subhashini, Pushpa, Ekta, Kiran, Reena, Mondos. Done up to this? Okay, that's good. Very fast. Okay, Bhagyalakshmi. Okay, someone from Baroda. Okay, Ekta. That's good. Right. This is our step 3. If you recollect, what were our steps? What were our steps? Here it is. First, we need to find out null and alternative. That is done. We need to check the assumptions, whether it is normal or not. That is done. Now we need to check the test statistics and the p-value. If it was normal, what about this 11.5? We need to check with that number. Okay, Vinay. Yeah, we need to check. But right now we are not checking our hypothesis. We are checking whether our data is normal or not. Why we need to check? Because we are checking our assumption, whether our data is normal or not. Why? Why so? Let me go take you one step back. Because of this. When you can use one sample t-test, when your data is scale, you can see hemoglobin was scale. Now we checked it is normal. What was our focus? Is was our average or standard deviation? It was average. And so, as hemoglobin is scale, it is normal. Our parameter is mean. So I can go for one sample test. If not, which I'm going to do next. If not, if it is not normal, then I have to go for Wilcoxon test for sign for the single sample. So Wilcoxon test I'll have to take it. So we need to understand which test we are doing it. And so for that, we are checking this whether the data is normal or not. So what we did, I'll repeat it again. What we did, yeah, we first thing, what we did was decision variable. What was our decision variable? Hemoglobin. And we know hemoglobin is a scale, but numeric variable. What was our focus, parameter of focus? It was average. It was not standard deviation, it was average. And so, as the decision variable is scale, is it average? We now need to check whether it is normal or not. If it is normal, we can go with t-test. If not, we'll have to go with Wilcoxon test. So, this is ideally whenever you come across a problem, first is to check what is your decision variable, which parameter is to be focused on. If it is scale, if it is average, next thing is to check the normality. And that is what we did over here. That is what we did. So now we go with step 4. What is step 4? To find out the test statistics T and the p-value. So which test to do now? One sample T test. So coming back to our Jamovi, I'll go into analyze, I'll go into t-test, I'll go into analysis, I'll go into t-test. Which t-test will be used over here? Independent t-test, pair t-test, or one sample? This is one sample t-test. I'll go with one sample t-test. Now this window pop up. Which is our variable? Hemoglobin. So select that variable over here. After selecting that variable, now we have to take care the point that Lata you were asking for. What is our mu value over here? 11.5. What is our alternative hypothesis? Greater than. See this. This needs to be checked. This needs to be tick marked. So what is the average we are comparing with? Mu we are comparing with 11.5. What is our alternative? Always we have to do alternative only. It is greater than. So here my test statistics, see this value 11.5. What next? Greater than. Because what is my alternative? Greater than. So once you do this, you can see my test statistics value. See on the right hand side, one sample t test. Here it is. Here it is, one sample t test. The result. Okay. Fine. What is the test statistics t value? Minus 1.30. So my test statistics is minus 1.30. And what is my p value? 0.893. Now we go with step 5. Step 5 is to compare our p value with alpha. What is our p value? 0.893. So what you can say? 0.893 is greater than alpha. Yeah, it is greater. Greater means what? Therefore, greater means we accept. That means we fail to reject null hypothesis. Fail to reject means what? We accept. What we accept? The null hypothesis. What was our null hypothesis? This was our null hypothesis. So I'm doing this so that in one screen you can get an idea exactly how 5 steps are done. So I'm not doing it slide by slide. So here we can say we fail to reject means we accept the null hypothesis. Therefore, we can say mu less than or equal to 11.5. Thus, what we can say, HB in schoolgirls is not more than 11.5. Clear? Any questions? Done. Okay. Now, if, okay, there is one in the chat bot. Okay, that's clear. Oh, perfect. Okay, Subhashri, Vina, that's good. So these are the 5 steps we need to do. Now we will be able to understand it that in case after doing step 1 and 2, in assumption, we get that it is not normally distributed. Then I cannot go with the t-test. I'll have to go with the non-parametric test. So step 1 and 2 will remain same, null and alternative. Step 3 is assumption. If it is normal, fine, go with t-test. You can see the test. Let me take that screen also. This I'll keep it permanently with you for reference. So what we did, I'll repeat again. What we did, we checked our hemoglobin. What was our hemoglobin? Decision variable. First, we know decision variable is K. We also found out that our parameter was mean. So this is a tick mark. This is a tick mark. So before going with one sample t-test, still one tick mark is left. What was that? It should be normal. So using Shapiro-Wilk test, we checked it is normal. And so I could go with one sample t-test. Now, again the same logic. if my variable is scale, my parameter is mean, that is average. I would say in general it is average, because now you know average, when I use the word average, it can be mean also, it can be median also, and it can be mode also. So in general, I'm using the word average. So this means, I repeat again, if your decision variable is scale, if your parameter is median, that is average, still you need to check whether it is a normal or not. If it is normal, one sample t-test. If it is not normal, I'll have to go with Wilcoxon test for single sample. So now we are moving towards that part. This is done. I already have the slides where I've already taken the screenshot. You can see this is null. This is the screenshot of the p-value that we got, that it is not normal. This is the test statistics, and this is the conclusion. But these are slide by slide, so it becomes difficult to recollect. And so now I'm having a blank slide in which I'll be doing it as if we are doing it on board. Now see the next data. Do it faster. Next data. This is the hard study data, where my variables are education, which is ordinal, none, primary, and so on. Gender, which is nominal, weight, height, smoking habit, and so on. Blood glucose level, and so on. This many variables I have it. These are the variables I have. What is my question? My question is the average blood glucose level 142? I want to check whether my average blood glucose level is 142. That is the question. Now think about it. This is the data. Okay, when you open up the data, you will find out gender, education, weight, height, age, smoking, physical, blood glucose, serum cholesterol, SCP, SBP, and so on. These are the data. This is the data. I'll start with the solution. So, which is the decision variable? Decision variable is, read the question again. What is the decision variable? Serum blood glucose level. Actually, we are talking about this part, SBP. That I'll explain. Okay, average blood glucose level. So I'll start. So this is glucose level. Now we know this is my decision variable. Which was my parameter? The word is average. So from this, I could infer that this glucose level is numeric, or I can say it is scale. My parameter is average. Perfect. Okay, Lata, Vina. Okay, Vina, that's great. So, now I'll go back to that chart. We are over here. Which was our decision variable? Blood glucose level. Means it is scale. One tick mark is done. Our parameter is average. One tick mark is done. What is the next part now? I need to check whether it is normal or not. Because if it is normal, I'll have to go with one sample to two. If it is not normal, I'll have to go with Wilcoxon test. This also can be done, but generally we don't prefer this. We'll go with Wilcoxon test for single mean. Getting the idea? So coming back to this. Now we'll go with all the 5 steps that are required. I'm starting with step 1 and 2. What is your step 1 and 2? Null and alternative hypothesis. Step 1 and 2. For that, what is the question? What is the question? Is average blood glucose level 142? What will be the answer for this? Yes or no? Perfect, Subhas. That's good. Okay. So this means, what is the question asked? Is average blood glucose level 142? What can be your answer? Yes or no? You can start with any one. So I'm saying here, average blood glucose level, I'm saying this, that average blood glucose is 140. What does that mean? Average blood glucose is 142. What will be complementary to this? What are the other options left out? When I say equal to, what are the other options left out? It is not 140. Average blood glucose is not 140. That's it. My step 1 and 2 is done. Out of this two, where you have an equal to sign, we have an equal to sign over here. So this is your null, that is H0. This is your alternative. Now I go with step 3. Step 3 means assumption. Assumptions is for normality. For normality, what is our null hypothesis? Our data. What is our data? Glucose level, blood glucose level. So we say blood glucose level is normal or is normally distributed. What will be alternative? Blood glucose level is not normally distributed. So now I need to check whether it is normal or not. And now you know how it is to check. Shapiro will test. So I'm opening my Jamovi again. I'll open a new file. What was the name of my file? Check the data. What was the name of a file? Hard study data. I'm opening that data. This, I'll say open. I'll have to search. Desktop. On my desktop, it is down. It is my hard study data. I've opened it. Ready with it? Okay. My focus is on blood glucose only. So now you can see blood glucose is showing a scale. That's fine. How to check that Shapiro-Wilk test? Now you know where to go for. You have to go for analysis. In analysis, exploration. In that, descriptive. Analysis, exploration, descriptive. Which is my variable to be checked? Blood glucose. I don't want all these things, so I'll go into statistics. I don't want N, I don't want missing because there are a lot of other data, minimum, maximum, not required. What is required for me? Shapiro-Wilk. Okay, got this? What it is showing? P, it is given already P less than 0.001. It is so small value that they are not displaying it. They are directly saying it is less than 0.001. So coming back to this part, what is my P value? Less than 0.001. I have to compare P with what? Alpha. What is alpha? 0.05. So if P is less than 0.001, yeah, P is less than 0.00, yeah, Subhash, perfect. If P is less than 0.001, I can say it will be automatically less than 0.05 also. If your value is less than 0.001, it will be less than 0.05 also. If it is less than 0.05, what we say? Therefore, we fail to reject. We fail to reject null hypothesis. Means what? Therefore, I can say blood glucose means I fail to reject. This is my null. Means I accept this. Is it so? No. No. What I can say, if it is less than, good. I was just expecting that question. Reject. Okay, Bhagyalakshmi. Okay, Shubhasri. I was waiting for I cannot say I fail to reject. I'll have to write down that I reject null hypothesis. And when I say I reject null hypothesis means this is rejected. So this means blood glucose level is not normally distributed. Getting it? Perfect, Bondos. Okay, Mandapati Kiran. That is not normally. So coming back to my table, where we are now, just check the tick marks. My blood glucose was scale. Okay, I ticked mark. It was average, tick mark. But it is not normal. Like this is not normal here. So I have to go for Wilcoxon test. Getting the idea how we narrow down to where to reach? Okay, now it is clear. I have to go with Wilcoxon test. So now in step 4, I have to go with a Wilcoxon test. I cannot go with t-test. So see what to do now. In this, we have to go with the same thing. Don't worry. Everyone pay attention over here. This important procedure that we are doing it. I will go with analysis only. I will go with t-test only. I will go with one sample only. All this remains the same because Jamovi is only the function, only the software which gives you parametric and non-parametric together. So I'm going with blood glucose. I've selected this. What was that case? What was the question? How much it was? 142. Okay, 142. So here I take 142. What was the case? Greater than or less than? What was my alternative? Not equal to. So I'll have to take not equal. Now everyone pay attention over here. All of you. This is the major differentiator of Jamovi with all other software. Here, it gives you the student T also and it gives you Wilcoxon also. So no need to remember that if it is not normal, then which test to use. It automatically gives over here Wilcoxon rank test. So we are going with what? Analysis. We are going with t-test only. So here it gives you the t-test value also. So we have tick marked over there and we are tick marked for Wilcoxon also. Getting the idea? Now we know that it is not normal. So I'll be requiring Wilcoxon. So see at the bottom, one sample t-test. At the bottom, I have done student T also and I've done Wilcoxon also. But we know if it was normal, I would have to go with student T. If it is not normal, I have to go for Wilcoxon rank. So no need to have a different menu for this non-parametric test. In the same parametric only, we can go with this test. And so my W value is 2831. And my p-value comes to what? 0.294. Now my step 5. Compare P with alpha. Alpha is 0.05. What was your P? 0.294. 294 is greater. Achha, by the way, we are doing Wilcoxon test, right? Now you know why? Because it is not normal. I think the picture is getting clearer. Yeah? Good. 0.294 is greater than this. Greater means what? We fail to reject. Am I right? We fail to reject null hypothesis. Fail to reject means what? In other words, we accept. So what we are accepting? This. So we say, thus average blood glucose is 142. Have I made things clear for you? Yeah, Subhash, perfect. Make it fast because we need to go for 2 samples also. So there are 4 tests waiting for you. We have completed 2 tests. One is t-test for 1 sample and we have done Wilcoxon test also. Any doubt? Manju, Nalini, Princey, Miruna, any doubt? Kanchan, Dr. Pauline, no doubt. I assume there is no doubt. That's good. Subhashi, no need to show. No need to show for t-test also. This was just a reference that I've given you. Perfect. Sure. So we now move towards, so 1 sample is done. So now we are moving towards 2 sample test. Okay, Dr. Augustine, that's good. So this is done. Now I'm going towards 2 samples. We'll make it fast. This slide permanently will be very, very helpful for you when to decide when to use which type of test. Sure. So now we are moving towards 2 sample test. Steps remain the same. I'm now going with 2 samples, but t-test. So the difference will be now, instead of taking 1 sample, we are taking 2 samples. Instead of comparing Karnataka's own result or Tamil Nadu's own result or Gujarat's own result, I'm comparing Tamil Nadu with Gujarat, Tamil Nadu with Kerala, and so on. If I'm comparing with 2 samples, I have to go for 2 samples which are independent. I've explained what is the difference between independent and dependent, but I'm going to repeat again. What are the tests for it? Step 1, step 2, null and alternative remains the same. Step 3 is assumption. Assumptions also, both the samples should be normally distributed, and that we can check using Shapiroval. Next assumption, which normally it is not given even in the books, but we need to do whether the variances are equal or not. Whether the 2 variances are equal or not. And that can be done by using F test. Or it is also called Levin test, or it is another test for that we can use. Okay, and then the test statistics and the conclusion. Why we need to do this? Because no books give this. Reason is, If the variances are equal, this is the t-test that we use, which normally is given in the book. But if the variances are not equal, this is what t-test we need to go for. This is well t-test. Well t-test. So we need to say Jamovi that you use this or you need to use this. We have to tell Jamovi. And for that, we need to check whether the variances are equal or not. This is something new, you will be understanding it. But use is compulsory. So now we'll start. In a fertilizer trial, the grain yield of paddy was observed as follows. So what is done in paddy or on paddy? There is one type of fertilizer that has been given, that is fertilizer using ammonium chloride. And this is the yield of crop I am getting from the different plots, different farms. If I use urea in different farm, then my yield of crop is this. My question is, find whether there is any difference between average yield of paddy due to the two different sources of nitrogen. I want to check, does ammonium chloride gives more yield or urea gives a more yield, or there is any difference between them or not? That is the question. Getting the idea? So you can see the farm in which ammonium chloride are applied are different than the farm in which urea are applied. So this is independent sample, because both farms are different. Okay, so now I'll start with the question. First step, decision variable. Anyone, which is the decision variable here? Check over here. What is the decision variable? Superb, Shubhashu. Anyone else? Others, please answer. What is the decision variable? Okay, Vina. What about others? Okay, Dr. Angana, Dilata, perfect, Pushpa. That's good. Kanchan, Kiran, perfect. Yield. Yield of paddy becomes my decision variable. Okay, Bhagya Lakshmi. Okay, Ekta. So I'll say my decision variable is yield of paddy. Which is that variable yield of paddy? It is scale, or we say it is numeric. That much is done. What is the parameter? They are asking about standard deviation or average. They are talking about average. So here my parameter is average. How many samples are taken? There are two samples. Why two samples? One, yes, okay, Mandapati, Kiran, Veena, perfect. Why two samples? One with ammonium chloride and one with urea. So you can have one sample, you can have two samples, or you can have more than two samples also. So we have exactly two samples over here. Which are the two? Ammonium chloride and other is urea. So you can see where we are. If I talk over here, where we are, my data is yield. My decision variable is yield. I have tick marked over here scale. It is average. That is also tick mark. It is two sample. That also tick marked is done. It is for two samples. Now I'm confused. Now I'm confused whether it is normal or not. Because now you know, if it is normal, I have to go with p-test. If it is not, I have to go with Mann-Whitney U-test. So what is the next step? Now you know. So before that, we'll go with step 1 and 2. Come on. So now I'm starting with step 1 and 2. What was the question asked? Is there any difference? So what can be the answer? Yes, there is difference, or you can say there is no difference. Suppose I start with there is no difference. Means what? Whether you apply ammonium chloride or you apply urea, yield remains same. There is no difference. So this means I am saying average yield by ammonium chloride and average yield by urea are same. What I am saying, whether you apply ammonium chloride or you apply urea, it is same. What will be alternative? There is difference. Means average ammonium chloride is not equal to that of. Clear up to this? Okay. Step 3. Assumptions. Now over here, be careful. How many assumptions we need to go for? There are two major assumptions we need to understand. One, both should be normal. And the second, variances are equal or not. I have to go with F test also. I have to go with Sapir-Whorf test also. So first I'll go with normal. Okay, I'll check the normality. What we assume in normality? What we assume? Null hypothesis. It is normally distributed. An alternative, not normally distributed. Make sense? But now you have to be careful. I need to check normality for both data for ammonium chloride, that is yield of crop for ammonium chloride, and yield of crop for urea also. So I need to check normality for ammonium chloride and normality for urea also. And now I'm opening my data where my data was given fertilizer.xlx. So now I'm opening that in Jamovi file. I'm opening a new data. Doing it now. Where it is fertilizer. I'm selecting fertilizer. We need to do it fast so understand it clearly. Is it done? Now, always check whether Jamovi has taken your data properly or not. Here you can see fertilizers are 1 and 2. That's right. Okay, that is ammonium chloride is 1 and urea is 2. Now here also the question arises, which is 1? How to understand that? Jamovi by default take alphabetically. So which were our data was ammonium chloride and another was urea. So by default, what it is does, ammonium chloride by default, it takes first. So it is always 1. And urea, it comes after that alphabetically. So it is taken 2. Jamovi always gives coding alphabetically. And so it is 1 and 2. So you can see over here, 1 is automatically taken for this, and that is taken by 2. But my yield of crop is actually scale. So I need to change over here. It is continuous. My yield of crop is continuous. That is done. Now it is fine. Now it is fine that my analysis data yield is scale and fertilizer is 1. So now I'm going into where to go for. I need to check I need to check normality fast. I need to check normality. So where to go? Descriptive. Once you open that descriptive, we need to understand, you need to check separately for urea and separately for ammonium chloride. So my decision variable is yield The advantage again for Jamovi, I don't have to do it twice. I don't have to do it twice. You just split your data by fertilizer. Split your data by fertilizer. So what will happen? Automatically your data will. How you can change 1 and 2, please show. Okay. If you want to do that, in data, you can see it is 1 over here. So if I click on fertilizer, it will show me level 1. Level 1, it by default it takes first level and second level, 1 and 2. So what it is doing it, ammonium chloride is taken as 1 and urea is taken as 2. Now if you want to change it, if you want to give ammonium chloride as 2, here you change the data, here level as 2, and for urea you take the level as 1. I would advise don't do that. Don't do that. Automatically it is taking alphabetically, so we'll go accordingly that. But you can change it. In levels, when it is nominal, in levels you can do that. Make sense? Fast. Analysis, descriptive. I've taken yield over here. I've taken splitted by fertilizer. Again, I don't want all the other things. What I don't want N, I don't want missing, I don't want minimum, I'm not interested in minimum maximum, I'm not interested in standard deviation also. What I'm interested in, Tapir oval. So you can see it is showing 1 and 2 separately. No, Vinay, no need to give in description. Okay, Kanchan. What it is showing you, one is what? Ammonium chloride. What is the P value? 0.754. I'm doing it directly over here. 0.754. So P is greater than 0.754, which is greater than alpha, that is 0.05. So it is normally distributed. What is normally distributed? This data of ammonium chloride is normally distributed. Same way, I will check for 0.172. So my P value comes to 0.172, which is again greater than 0.05. And so we say it is normally distributed. Make sense? It is normally distributed. Now I'll have to go with assumption 2. That is what? Whether the variances are equal or not. I have shown you either to use t-test, this one, or well test. Jamovi is again the only software that comes to the rescue for this. What to do? What to do, everyone over here? Because these are something new for you. Go into analysis, go into t-test, go into independent t-test. Analysis and this. Again, yield, I'll split my data for grouping. Now the magic. Here, you can see what is an advantage now. It shows you 3 things simultaneously. Go with the normal student t-test, go with well test, and go with Mann-Whitney U-test. You can take all the 3 together if you don't want to do it again and again. Here, Mann-Whitney is out of the question. Why it is out of the question? Coming back to this part, here you can see where we are. My data scale. We have checked both are normal. Here both are normal. It is about average. So it is about average. And it is for 2 samples. So now it is clear that I have to go for dependent t-test. But if it was not, it already gives you Mann-Whitney U-test over here. See in Jamovi, Mann-Whitney U-test. So no need to remember that what is a parallel non-parametric test for a t-test. It will automatically give you. Okay. Now the question arises, how to do check whether it is student t-test or a well test. This means how to decide whether it will be this test or this test. How to decide that? It is whether the variances are equal or not. So that is called homogeneity test. So here you can see in assumption check there is homogeneity test. There is a homogeneity test. So it is F test or Levin test you can go for. What is the value of P? What is the value of P F test? We'll say it comes to 0.014. We are here. Here. So now I'm doing, this was the first assumption, that was normality. Now I'm going with the second assumption, that is homogeneity. Homogeneity means variances are equal or not. What is my p-value? 0.014. You can see this. 0.014. We'll go with 11 test, so that is p-test. It is less than 0.05. Right? It is less than 0.05. Less than means what? We reject. We reject null hypothesis. That means what? Therefore, variances are not equal. If variances are not equal, coming back to this, you can see here. If variances are not equal, I cannot go with this test. Okay, if variances are not equal, I cannot go with this. I have to go for the well t test. So now I'll say, as the variances are not equal, therefore, so we use well t test. And that comes step 4. P-value and p-value. So you can see in Jamovi, it is showing me two values. What it is showing me in Jamovi? You can see this independent t-test here. Everyone here. It is showing me students t also, and it is showing me well t also. But now we know, because of the homogeneity of variances, that I have to go for well t test. And what is the value for that? 0.012. 0.012. What is the p value? 8 minus 3.43. So what we can say from this? P is 0.012, which is less than 0.05. If it is less than 0.05, what you can say? Therefore, we reject null hypothesis. What was our null? This was null. We reject this. That means there is difference. So thus, there is difference in average yield of crop. How this is useful? This means if we want to check whether the fertilizer affects the yield of crop, the two fertilizers that we are using it, is it affecting the yield of crop? The answer comes, yes, it is affecting the yield of crop. Then you have to make a call. Okay, there is a difference. Then the next question arises, which is better then? I got an answer that the yield of crop is different. Then the next question comes, and which is better? Is it urea I have to use it, or it is ammonium chloride? And for that, you have to go with the mean value of it. So if you go with mean, here you can see what is average yield for fertilizer 1, 40.6. That means for ammonium chloride, if I use ammonium chloride, my mean comes to 40.6. But if I use urea, my yield comes to 57. So I can say go for urea only. If you want to use fertilizer and get more yield, go for urea. This is how things goes for independent sample. I will not explain now the other way around, because now you know that if I go for this independent t-test for it, which is an alternative if it was not normal. Here, if it is not normal, if I got the answer, any one of this, if any one of the two variables, that is ammonium chloride or urea, any one of this, if it was not normal, here both should be normal. But if any one of that is not normal, I cannot go for t-test. Which test to go for then? If it is not normal, now you know. If it is not normal, then I have to go with Mann-Whitney U test. So for that, what to do? Simply tick mark in Jamovi, here Mann-Whitney U test. Simply tick mark only. Automatically, you will be able to conclude using Mann-Whitney U test. That is the beauty of Acha, Bhagyalakshmi. Once you get the idea that which we got the conclusion. What was our conclusion? Conclusion was there is a difference. If you get there is a difference, then go with the average. That is in the descriptive part. Here you can see in the descriptive. Here it is descriptive. We already have found out descriptive. In descriptive, compare the means. Mean in descriptive, compare the means. Whichever mean is more, that fertilizer is better. Yes, Veena, you're right. Bhagyalakshmi, it is clear? Okay, that's good. Now we go with the next part. Interesting? I'm sure Jamovi will make your things life easy for all the analysis easy for it. Because automatically in one click you are getting both the answers for it, whether it is this one. Okay, Mandapati Kiran, okay, Jyotish, okay, Subhasini, Veena, that's good. Now we go with the next part. See, I've done already, this screenshot is ready with me. But I'm not going with a screenshot because I will be doing it as if we are doing it on the board. So it becomes easy for you. Okay, now we go with pair t-test. Thank you, Veena, for the compliments. Yeah, Dr. Angana. If one is normal, other is not normal, we cannot go with t-test. We can go with t-test only if both are normal. If both normal, then only go with t-test. If any one of them is not normal, or if both are not normal, then you have to go with the non-parametric test. Mann-Whitney. Wow, Veena, that's good. Now we go with the next part. So now we'll have a data where it is what sample units are same. If the sample units are different, then it is independent t-test. Like I am comparing participants of this workshop and the participants of past workshop. Both ways, I want to find out which on an average, which participants were better. It was for workshop 3 or workshop 4. Suppose I want to compare this. So here both the participants are different only. Then it is independent. But if I say they are same, I am checking your Jamovi knowledge before this session and after this session. So participants are same 30 participants, but it is just like before and after. Then we have to go for dependent t-test. So in short, dependent t-test is used when the sample units are same. Okay, Kanchan, good. Likert scale, it is called which type of level of measurement it is called? Ordinal. And if it is ordinal, we have to go for non-parametric test only. Whenever it is a Likert scale, it is nothing else but an ordinal level of measurement. And for ordinal level of measurement, we'll have to go for all non-parametric. Means I cannot go for t-test. I have to go for Wilcoxon test. I have to go for Mann-Whitney U test. Am I clear? Kanchan? Okay, that's good. Now here when I say the participants are same, sample units are same, so I will not check individually. I will not check individually. What I'll do is I'll take the difference because units are same. You can see the IQ level. If I go with this, what is the case? Suppose participants are same, 31 participants. It is before the workshop, after the workshop. So my focus will be difference, D, after minus before, or before minus after, depending what you want. So I will focus on the difference now. I'll not focus on individual observation. That is why it is called paired t-test. Because why it is called paired? Because for each observation, we get before and after. So this is a pair, x comma y. For next, before and after. That is called a paired t-test. Okay, so how to do is the things are same, but the only difference is we'll check the differences. The difference only will be normally distributed or not, we'll check that. Okay, so we'll start with the sum. We have a data iron contents of fruits before and after farmyard manure was observed as follows. Means before applying the farmyard manure, this was the iron content in the same plant. So what I'm doing it, I have taken plant, I collected the fruit from it, I checked it iron content. Now on the same 10 plants, now I'm applying the farmyard manure. And now again, I'm collecting the iron content in the fruits that I get from the plant. So the question is there any significant difference between the average iron content in the fruits after applying the farmyard manure? Farmyard manure, that is the question. So what I'll do now, I'll first start, the data will be given in this way. Before, so these are the 10 plants. This is before applying the farmyard manure, this is the iron content. And this is the iron content after applying it. Okay, so I'll start. I'll start with step 1 and 2. What is the question asked? Repeat it again. Is there any significant difference? And they are not asking whether the iron content has increased or not. If that was the case, hypothesis would be different. Here the question is asked, is there any significant difference? So I will say there is no difference. No difference means what? D is equal to 0. Whether you apply the farmyard manure or do not apply, there is no difference in the iron content. What will be complemented to this? There is difference. Means B not equal to 0. Out of this two, null hypothesis equal to means over here, alternative is this. Step 3, there is only one assumption, and that is for normality. This is much easier. What is our null hypothesis in this? Difference is normal, normally distributed to be very precise, and alternative difference is not normally distributed. Okay, then which was our data? Fruit and content. So I'm opening the Jamovi file. Okay. Data. What is the data now? Before and after. Okay, this is before and after. First thing is to check whether the data is normal or not. Again, the advantage over here, Jamovi is again making things life easy for you. For dependent sample, we don't have to check individually. Am I right? We don't have to check before is independent, before is normal or after is normal. We don't have to do that. We simply have to go for difference. So directly we'll go in analysis, we'll go in paired t-test, we'll go in paired. You take a call. What do you want? After minus before? Okay, I want after minus before. Automatically it is taking difference. See on the right hand side. Automatically it has gone for after minus before and student t-test is done. Now we don't know whether student t-test will be applied or not. Why? Is it normal? We have not checked it. Because if it is normal, it will be t-test. Now you can see the Jamovi fun. If it is not, Wilcoxon rank is already there for you. Isn't it? How to check? Here at the bottom, there is an assumption normality test. Click on that. It will show you this many tests for you. This is only applicable for paired t-test. So be conscious. Not it assumption check will be shown for independent t-test also. But don't go there. Because we need to follow the steps whether it is normal or not. Otherwise, we cannot. In paired t-test, we will go with normality test from directly this test. We can go for that. Here it will not, Veena, here it will not take alphabetically. Here we will have to give it because it is a difference. They are not independent. So we have to go for the difference. So we will have to mention that okay, you want after minus before or before minus after. That is your call. So here I am taking after minus before because see what I have taken over here in this. I have taken difference. And D I am taking it as iron content after applying farmyard minus before applying. Now you can see what is the value of P for normality. You can actually, for normality, you can go for Shapiro, Anderson, Darling test, Kolmogorov-Smirnov test, but generally we'll go for Shapiro. So what is the value of Shapiro P? 0.536. Greater than 0.05. Greater means we fail to reject. We fail to reject means difference is normally distributed. If we again go with that, yeah, over here. What is happening now? What is happening? My data was scaled. So here it is a tick mark. They are talking about average. We have two samples. They are dependent and it is normal. So normal means I can go with this. If it was not normal, I'll have to go with Wilcoxon test. So here, fortunately, our data is normal. So now I can go with step 4. As it is normal, go for Jamovi. Which test to use? I have to go for student T. What is the value of student T? 0.655. T value 0.655 and P value 0.529. So now I'll conclude in step 5. P is equal to 0.529 greater than 0.05. Greater means what? Greater means we fail to reject. We fail to reject null. Fail to reject means we accept null. What was null? There is no difference. So the farmyard manure is not making any difference in iron content of the fruit. So no need to waste money on it. Whether you apply or not, there is no difference in the iron content. That is what the result is showing it. So no need to spend on farmyard manure to increase the iron content. Same thing now, if I say, if I would have got that the data is not normal, say by chance, if it was not normal, then what is the easy part? In Jamovi, go with Wilcoxon. Here already we have. So that's all, 0.575. Okay. So that is an advantage of Jamovi, that parametric and non-parametric can be taken together. Okay, so what I'm doing it now, I'm sending you all the files over here. This is a whole data set that I'm sending. You can practice it as many sums as you want. There are a lot of sums, lot of case studies given to you. There is a Word file which gives you the case study and correspondingly data is also shared. Now you know the whole process. I'm sure once, how to do now? Practice with the same data that I've given over here first. Then practice with the practice data that I've given it. And then try it for your own data set if you have it. So that completes the whole cycle. You have learned on a particular data set, first do it that only, hands-on. Once that is done, similar type of data set that we have shared, practice on that. And once that is also done, then go for your data set for your research that you're going on, for your project that may be going on, or all you can do it. Okay, any questions now? I hope Jamovi is easy now. At least that much, I'm sure this session would help you out. Okay, Bhagyalakshmi, thank you. It's clear, that's good. Okay, okay, Dr. Paulin, Reena, Lata, Dr. Angana. Yeah, Subhashri. For paired only, you can go with this. Okay, Subhashri. The Bhagyalakshmi zip file is not opening. Anyone else have tried? Okay, Donga, Subhashri. Very clear. Thank you. Yeah, that was the main purpose, Veena. That was the main purpose, that it should be clear to everyone.
It is opening. Permit is opening. Zip file.
Sending it individually. It's opening, yeah.
Working.
Yeah, Veena, don't pay anything for it if it is not opening. It is zip file, so they are asking to pay 75 to unzip it, because that is the license version that you might not be having it. That's the reason. But I've sent the file separately, so that won't be an issue. Pauline, you don't have to now. Devana, you don't have to do it, because I've sent across the files separately, Excel file and Word file and everything. Princey, it is clear? Goana, Anita, okay, that's good. Done. So we'll stop over here. If you don't have any questions, that's good. But do practice. Things seems to be easy when someone is explaining it to you, but unless and until you do it hands-on, you practice, then the real picture starts. But Jamo will make the life easy. That much I can assure you. It will be very, very easy for you to do all this analysis, parametric and non-parametric together. Okay, done. So tomorrow Raju sir will be taking an extension of this. He'll be taking ANOVA, and after that, Wednesday, it will be my last session. That will be for correlation and regression. Okay, Shailila ma'am, that's all for today.
Yes, sir. Thank you very much, sir. We extend our heartfelt appreciation to you, sir, for your outstanding expertise and dedication in guiding us through this session on parametric and non-parametric tests. Your ability to simplify complex statistical methods and explain them with clarity has empowered us to confidently apply these tests in various research contexts. Through your engaging presentation style and interactive approach, you fostered a dynamic learning environment where participants actively engaged with the material and gained a deeper understanding of statistical inference. Thank you very much, sir, for your wonderful session. We will meet on Wednesday, sir. Thank you.
Thank you. Thank you, ma'am. Okay. See you on Wednesday. Bye.
Good night, sir.
Good night.
Okay, thank you, participants. We will meet tomorrow at the same time. Thank you so much. I think you have all downloaded the files. Please download, then I'll write. Please do it. Yes, we will send all the files to your mail. I have downloaded, but some are not opening. Some files are not opening, like insulin. Whatever I have downloaded, I will send you to your mail.